Okay, so away we go. So what we're going to be looking at today is we're going to begin our look at Chapter 4, Fundamental Issues in Research. And we're going to start off with a look at variables just in general and operational definitions, a very, very important concept necessary in order to even do research. Now, before we get to that, I want to make everybody aware of a logic puzzle makeup opportunity. So you recall that I mentioned deductive reasoning, super important, super critical kind of skill to have just in general life. Never even mind needing to be a critical thinker in experimental psychology. Just in general life, the ability to reason deductively is such a hugely important aspect of surviving in today's world. Because of that, I want to make sure that everybody here develops their skills to the best of their abilities. So, the logic puzzle on the exam is going to be bonus towards your exam score. And if you did not receive a perfect 5 out of 5 on that bonus logic puzzle, that is, if that logic puzzle showed that we still need to work a little bit on these deductive skills, then what you can do is you can actually go online and solve additional logic puzzles to help increase your score. So just so that you're aware of this opportunity, it's at the Puzzle Barons Logic Puzzles. So this link is available through Canvas. If you go to the modules, it's got that link right there. What you'll need to do in order to earn the missing bonus points, number one, you need to register for free. So it is a free service, but you do need a registered user profile. So you can just register, and then every time that you go there to earn points, make sure that you log in. And the reason for that will become apparent in just a moment. So you always have to log in order for your logic puzzles to count. And that is because this will track whether you use hints and whether you use check the puzzle, check for errors in order to solve the puzzle. So because this is an online service, because it's for some it's meant for as a fun pastime like Sudoku or whatever, there is a little hint button, and you could just sit there and click hint, 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 and it will literally fill in your entire puzzle for you. That's not going to help us practice our deductive reasoning skills. You can also put check for errors, and it'll show you the boxes that you have incorrect, i.e. it'll show you the correct answer. It's either yes, this box is checked, or no, this box is an X. So the check for errors will let you know if you're doing things incorrectly as well. And again, you can just game these two systems here and not have to use any deductive reasoning to solve your entire puzzle. So that's why we're not allowing them for your bonus points. So when you log in, it will track how many hints you use and how many times you've checked for errors. And that tracking needs to be 0 in order for your puzzle to count towards your missing bonus points. The puzzles have to be at least 4x4, so the ones that we've been using, like we've been encountering so far. And then what you will do is, once you get to your congratulations, you've solved it, upload your screenshot. So take a screenshot. There's a number of different ways that you can do that with the snipping tool, for example, in Windows. And then just upload that to Canvas, and it has to be saved as an image. So JPEG, GIFs, PNGs, bitmaps, any of those formats are fine. Just save it as an image and upload it. So what you're basically looking for is this page here. So once you solve it, congratulations. And then it will mention your puzzle time, and importantly, it'll mention whether you received any penalties. You receive penalties for hints, and you receive penalties for check errors. So what I'm looking for is that no penalties indicator there. And then this is what I need to verify that, yes, indeed, you did solve this particular puzzle. It can be a 4x4, it can be higher, it can be easy. So you don't have to do like the moderate or difficult levels, you can just do the easy levels. Again, we're just looking to get that practice in. So that'll allow you to earn extra points towards your any missing logical puzzle points. Any questions on that so far? Mm-hmm.
How many points can we earn?
That's the next thing. All right, so how many points can you earn? What this point, so this is a graph of how you earn points. You can earn up to the entirety of the 5 out of 5. So this is for if you started at 0 out of 5. So let's say you didn't get a single line correct. The way that this works is this is a system that is geared towards growth. It gives you the most for completing your first puzzle and then slightly less for completing every single other one. So it gives you a lot of encouragement at the beginning when you probably need it, but then it also has this diminishing returns where it gives you, it encourages you to practice multiple times. So how this works is you will always be awarded, for each new puzzle that you complete, you will be awarded 25% of the points that you're still missing. So if you're missing all 5 points, you got 0 out of 5, that first puzzle that you solve and submit, that'll take you up to 1.25 out of 5. That second puzzle you submit will take you up to about 2.2 out of 5. The third one, about 2.9. The fourth one, 3.5. So you get a big boost for the first puzzle, and then you continually get boosts, and you can solve as many as you want in order to get to basically 4.99999 at some point. So this is the way that it'll be scored. So this is your graph, and these are in the PowerPoint student lecture files. So if you're wondering whereabouts you are, you can just find out your situation. So if you got a 0 and you solve 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you're getting over 4.5 out of 5. If, on the other hand, you only got one line correct, that first one is worth 25% of your missing 4 points, so it's worth 1 point. So your first puzzle takes you from 1 to 2, and then so on and so forth as you solve more. If you got 2 out of 5, here's your graph. If you got the extremely rare 3 out of 5, which is rare because if you get 3 lines correct, you got that one last line left over. So this is probably if you misread your output. But still, if you made that error, this is your curve that indicates how many points you can grab. You can't get 4 out of 5 because if you get all 4 rows, you get 5 out of 5, you get the bonus point. So that's how much each additional puzzle is worth. And I love this setup because it is, again, rewards you a lot for the first puzzle, so kind of to get going. And then kind of keeps you going, because if you didn't get 5 out of 5, that's an indication that we need a little bit more practice. We need to try, do this a little bit more. And I have had students that have handed in 20, 30, 40 puzzles, and it gets to the point where some of them actually, believe it or not, enjoyed these, kind of like doing a Sudoku puzzle, and you will get very fast. So do not be surprised if that first one maybe takes you 20 minutes, I don't know where your skills are, maybe takes you half an hour, maybe you have to abandon it and try another one, But then I've assessed this. When I look at the times for the later puzzles, they go down and down and down, and they get to the point where they're doing them in 2 minutes, 2.5 minutes consistently. So yeah, that's the situation. So if that applies to you, I'll be grading the exams and posting those scores, and we'll take a look at the exams in a future class so that you know exactly what situation you're in. But that's how you can earn some extra points and practice your logic skills as well. So the deadline for this submission is to submit this is Monday, October 14th. So we got a bunch of time by midnight, and that's literally midnight before exam number 2. So completed puzzles, if you submit them, will be applied to exam number 1. We will do this again for exam number 2. We'll do it a final time for exam number 3 as well. All right, any questions before we move on to the content of today? All right, so fundamental research issues, what are we going to be looking at? So we're going to first talk about the library assignment, make sure everybody's ready for the next class. And then we're going to talk about variables, what they are, how they're used, and very importantly, we're going to talk about the operational definition of variables, which is a very necessary way of allowing experiments in science to be done on these sometimes difficult to measure constructs. So we're going to talk about the benefits and construct validity, and then we're going to briefly take a look at relationships between variables, correlations between variables, and talk about the different types of relationships. And then we'll mention what a relationship does. If you find a relationship between two variables, what does it actually do, and how does it reduce any uncertainty? All right, so your library assignment, it's in Canvas right now, so you can download a PDF of it. You will have access to that. It's going to be due September 30th. So we have September 24th, is when we're having the instruction on how to do it. So you have slightly less than a week to do this, so you'll have plenty of time. So what you're going to be asked to do is you're going to be asked to find articles that satisfy the requirements. So there's 4 questions. You're going to find 5 articles, but they have to satisfy certain requirements. So the first one is you need to find the most cited article that is about or regarding reconstructive memory. And the clue for you is that this article cited Dease 1959. So Dease 1959 is a paper. It was a memory recall paper. It's available in Canvas in the research paper resources folder. You can now just download the Dease PDF. It is, and we'll talk about this a few times this semester, it's not well written. And it was basically a groundbreaking article that should have moved psychology forward immensely, but unfortunately was buried because it just was not written well. And scientists are humans, and when we come across something that is difficult to muddle through, chances are we'll miss the point or maybe not even read it. There was another article that came later that broke open the floodgates on reconstructive memory research, and that article cited Dease. So that's your first clue. You need to find this one article, the most cited article, and your clue is that that article actually cited Dease. So we'll see how to use the databases to answer this, to find that one particular article. When you're handing these in, and this is very important, you have to name your article the question number that it's the answer to, and then whatever you want to name it. So whatever article you find, name that when you submit the PDF files. Name that 1 dash, and then whatever name you want to choose it, that 1 dash is what's going to tell me that this is your answer for question 1. Because you're handing in 5 articles, and I cannot determine sometimes which one is in response to which part of the library assignment. So make sure you're using the naming convention. There will be points for doing that correctly. All right, so number 2, the second article you're going to find. You got to find one more recent primary research article. So remember how to identify a primary research article. You're looking for subjects, characteristics in the methods. You're looking for statistics with a lot of jargon. You're looking for primary research articles about reconstructive memory. So this one is open. It's just within the last 10 years. And this one is completely up to you. So different students will hand in different articles that they found. This one, if you find one that aligns with your own personal interest in psychology, feel free to do that. So if you find a developmental paper that is about reconstructive memory, awesome if that's what you want to do. If you find one on autism that is reconstructive, that's great. Whatever you find, it just has to be recent. It has to be within the last 10 years. Number 3 is more straightforward. Just find Weldon and Bellinger's 1997 article. So no title, no journal, but enough information. So this is kind of the situation that you encounter when you're working off a citation. So if you read a citation, it'll say Weldon and Bellinger 1997. Is that enough to find it? Yes, it is, and you'll find out how. And again, this is the 3rd article, so name that 3 dash, and then whatever you want to name it. And then finally, for the 4th question, you're going to find 2 articles. These articles have to either be highly cited or they need to be recent. So it's very difficult to get both of those. You don't need both, right? It takes years to get citations occasionally. Recently published articles in 2019 couldn't possibly have a citation because they've just gotten published. It takes about a year in the publication cycle for papers to come out. So either something that's classic and highly cited, or something that just came out, primary research that is about group memory, and you got to find 2 of those. So name one for A, whatever you want to call it, name one for B, whatever you want to call it. And you will be submitting a total of 5 articles. You will be submitting the PDFs. So we're not submitting links to where these articles are. We're not submitting just the reference information, like, oh, this is the title and this is the author. You have to actually download the PDF and then upload that through Canvas and Canvas assignments. And so make sure that when it's asking for recent, you got it recent. Make sure that when it's asking for highly cited, you got it highly cited. And again, 4 is or. So they can both be recent, or they can both be old and highly cited, or you can have 1 highly cited, 1 recent. Whatever it is, they just need to satisfy that criteria. All right, any questions about the kind of what the library assignment is asking? All right, so citations and references. You'll see that a lot of this has to do with citations and references. So let's talk about that a little bit. Citations are the sources that you used. There it is. So, sorry, references are the sources that you used in your article. So when somebody says, oh, does this article have a lot of references? What they're asking is, does that article have a lot of information or a lot of background literature that it used in order to write the article? So the references are the sources that are going to be used in your article. Citations are the articles that use your article as a source. So when I say that a paper has 30 citations, what I mean is that 30 other published articles included that article in their reference section. They mentioned that article in their work. They mentioned that article in their publication. So once you know this, you can start using citations and references in order to very quickly help you evaluate certain articles, right? It can be used as a shortcut if you're not familiar with an area, if you're trying to find new research. This can really help you because if you take a look at the reference section, if you open up a PDF and you just go to the reference section, when you become familiar with an area, even just a little familiar, you'll start to know what the classic papers are. You'll start to know what the classic researchers are. And you can take a look for them in the references. And the better the sources are, that typically, not always, it's a shortcut, but that typically indicates a better article. So if I'm looking at a group memory research paper, I'll go to the reference section and I'll look for Weldon and Bellinger. And if I don't find Weldon and Bellinger, that tells me probably down a notch, right? Because Weldon and Bellinger is a classic piece of group memory literature. If you're not mentioning it, that is an indication that maybe your research has not been as thorough. So references can help you navigate, and then citations can also help you navigate an area, and they're extremely powerful because if you can use citations to search for your articles, and we'll see how to do that on the library visit, the more citations typically indicates a more important article. Important is a big word there. Usually it's better, but sometimes controversial articles that are not very good, will get highly cited just because people will cite them in as saying, this article was horrible, Smith and Smith, 1942 or something like that. So sometimes, you get a bad article that's highly cited just because everybody's talking about it, but usually it means that it's a very important article. So if you can search by citations, which we'll learn how to do, even if you know nothing about an area, you have no idea who the important researchers are, what the classic works are. If you can get into that area and then search by citations, you will immediately know, here's the top article that everybody is talking about. Here's the second article. Here, you can very quickly find the top 10 articles in a field looking for these, searching by these citations. So it's a very powerful method, especially in your situation here, where you're learning about new areas of psychology, and you might not know, who are the important works. So just to kind of give you a visual of what a citation means, and just to let you know what happened to Deese. So there was Deese in 1959. And Deese wrote his article, and it should have been groundbreaking, and everybody should have been talking about it, and it should have moved the science of psychology ahead massively, but it was poorly written. You're going to have to read it. I read it. You'll read it. It's a good lesson in terms of why writing is important, but it stayed buried. It wasn't very influential. Decades later, right? This is the article you'll find. Decades later, two researchers read his article and almost literally said, let's just redo this experiment. We'll redo this experiment. We'll do another one that's a little bit different to kind of push the research. But let's just redo this experiment. And they wrote it up, and they wrote well. They were very clear. They were very concise. They communicated effectively. So Deese got one citation. These guys said, we're using Deese. Deese is one of our sources. They wrote well, though, so somebody else said, oh, this makes sense. I'm going to cite them as a source. And so did a bunch of other people. So all of these researchers here basically said that this is an important piece of research by including it in their work. And if you don't know an area, this is a very good way to say, what does everybody else think is important? And if you know how to use citation searches, it'll lead you right back down to this classic paper, and you can do it in 10, 15 minutes easily. So that's why we're going to be working with citations. It allows you to navigate through that subject area very efficiently, even if you have no idea what that subject area is. And that is why we have those requirements. Find the most highly cited article, find an article with 30 or more citations in our library assignment. All right, so that's a preview of your library assignment. Any questions on that? So we will be going over the skills that you need to complete this on Tuesday. I will again in Canvas put out the announcement of where we're going to meet, and just be ready to go and do review how to find primary research articles, because we will encounter a lot of secondary research articles doing this assignment. Those will not count for this assignment. You need to find those primary research articles. All right, that's a library assignment. Let's talk about variables. So a variable in science in general, and therefore in experimental psychology as well, a variable is any event, situation, behavior, individual characteristic that varies. So that is a very important concept. It has to be able to be different. It has to be a behavior that can change or changes amongst individuals, or maybe within an individual. It's got to be something that changes or can change. It's got to be an individual characteristic that varies, some event that some people experience but other people don't. It needs to be a behavior or a situation that is able to be different, able to vary, able. So one classic example is height. Height is a variable because you can be different heights. So these are the heights of a lot of leading men in Hollywood, and you can see Kilraven over here, 5'10", Magneto, 5'11", Bane, 5'9". That was surprising. They actually used a lot of techniques to make him look taller. And then we got Loki right there and Thor right there, getting to 6'2", 6'3". But the key thing here is that height is a variable because it can be different. You can get people that are above 6 feet. You can get people that are below 6 feet. It's something that can be different between different individuals. Some Hunger Game fans are surprised.
He's 5'5".
You know, you know.
They make him look so much taller in the movies.
You know what happens to childhood actors? I don't know if he was a childhood actor, but he was. You'll notice that there's not a lot of childhood actors here. And you'll also notice that oftentimes a childhood actor will sort of just, go into the, off into the sunset. One of the reasons childhood actors are so good at what they do is because they look incredibly young. If you're playing a 5-year-old in Hollywood, you're probably 10, right? You're probably 9, 10 years old. And those are the individuals who just naturally aren't very tall, because that's one of the things that makes you look young. So you get somebody like Elijah Wood, right? Great child actor. Great actor in general. He's not very tall, right? So and you couple that with the fact that Hollywood likes their leading men, tall, dark, and handsome. That's the kind of cliche, and that's what happens to a lot of childhood actors.
I'm gonna be honest, I'm more upset that Michael B. Jordan's only 5'10".
Yeah, I know. Well, there is that, there is like that 6 foot threshold, right? It's kind of like that standard that they want to get. So.
They must surround him short.
And then because Star-Lord there, because leading men are supposed to be tall and taller than leading ladies. People that are women that are naturally tall, like Nicole Kidman. Gina Davis, I think there was one more. Daryl Hannah, I think, was super tall. Natasha Henstridge was really tall. They have trouble finding movies that they can be in because you don't want to put them next to Dave Franco, right? And Dave Franco saying, "I need you in my life. You have to be, here with me." So, all right. So, anyways, variable. Let's get back to the method at hand.
You pull Michael B. Jordan up.
Speed. So speed, a behavior, the ability to run the 100-meter dash, that's a variable, right? How fast can you run the 100-meter dash? So that's, his name just ran out of my head. He's like, Usain Bolt, thank you. That's Usain Bolt when he set the record, 9.58 seconds. Nobody's ever been that fast again. And it's variable. Some people are above 10 seconds, very few are below 10 seconds, only 12 people in the history of the world have run 9.82 or less. He's the fastest male, and there's your fastest female. Does anybody know who this is? This is Florence Griffith Joyner. She set the record for women back in 1988, so nobody has broken it since. And she clocked in at about 10 and a half seconds. So variable, right? Over 10, under 10, it can be different. Other things that have, so it has to vary. A variable has to be different, has to be able to be different. And what we call those different amounts of a variable, they're called levels. So height has a variety of different levels. You can be 5'5", 5'6", 5'7", 5'10". A variable has to have at least 2. You have to have at least 2 variables where you can be this or you can be that at least. You can have more, but you need to have at least 2. So an example of a variable that used to only have 2 would be gender. So not that long ago, there was 2 genders. You were male or you were female. Now it's a variable because it's different across, in this case, it's an individual characteristic. Some people were male, some people were female. What's happened in the intervening years is that more levels to this have been added, right? So now there's more, it's on the continuum, and there's different different ones on the continuum, and I don't know the name of any of them because they continually change, but importantly, many more levels than there were before. If you take a look at things like sexual orientation, if everybody was heterosexual, sexual orientation would not be a variable, right? Because if everybody's heterosexual, it doesn't vary, so it's not a variable. As soon as you add one other level, so we got heterosexual, we have lesbian, now it's a variable because people can be different things. And as we probably have encountered, there is a lot of levels now for sexual orientation. Actually, so many that they put in the plus. So the LGBT, I forgot the I, the LGBTQIA got so long. I mean, it's just difficult to say. Where you're like, oh yeah, the LGBT, foundation, the LGBT parade. Well, what about this one? Okay, so LGBTQ. What about I? What about LGBTI? It got too much, so they just put the plus. This is everyone else. And again, we have at least 1, 2, 3, 4, 5, 6, 7. Got the I. 8, 9 9 levels that sexual orientation can take. All right, so that's the idea of variables. And variables in psychology, things like cognitive task performance. So do you have a fast reaction time, slow reaction time? Can you remember a lot of words? Can you not remember a lot of words? Do you have a high IQ? Do you have a lower IQ? Those are variables. Levels of depression, some people are highly depressed, some people are not. Levels of intelligence, I mentioned that. IQ scores. Reaction times. So if you're a boxer or a goaltender in a professional sport, you have very quick reaction times. If you're not good at those skills, you got poor reaction times. Rates of forgetting, aggression, speaker credibility, attitude change, anger, stress, age, self-esteem. There's a ton of variables that we have in psychology. And importantly though, it needs to be something that can change. It needs to be something that can vary, at least between individuals. So being born is not a variable in psychology because, as far as I know, all of us have been born, right? So that's not a variable because somebody can't be here saying, I wasn't born, I'm different on that. Well, you can say it, but it's not going to be true. But that's the thing, like it has to vary. So always be aware of that. It needs to be able to be different across different individuals. Do you have a question or?
No, I just saying
you were
I'm
just,
alive.
yeah.
But self-esteem, is that kind of a weird one though? That one kind of varies.
No, it does. Exactly.
People can lie about that though. Would that kind of alter it?
Well, we'll see about what to do when people do lie about things. And that's one of the challenges of psychology is measuring these things that you can't kind of objectively measure or you can't directly measure. So if I told you measure height, you could measure height and you would be very exact, right? And everybody would agree, right? So if people measured me, let's go back to Michael B. Jordan. If you measured Michael B. Jordan, you'd be like, he's 5'10". If somebody else did it, they'd be like, he's 5'10". And clearly we're measuring his height. When you measure something like depression or self-esteem, you can't see it. I can't go to you with a tape measure and say, this is how much depression you have. So we need to have ways of measuring it, and the ways of measuring it are not always clear whether they're the right way to measure it. So like you said, with self-esteem, people might lie. And there's a number of different measures for self-esteem that try to get around those issues. And we'll talk about that when we talk about things in validity. So things like face validity and test-retest reliability, things like that. All right, so importantly though, all of those can be different. In a single person over time, in different people, that's what makes them variables. All right, so once you have a variable, right, let's stick with depression here. Let's say that you've determined, yes, people differ on depression, and you want to do research on depression. One of the first things that you need to do is you need to come up with an operational definition of depression. And this is so you can actually do the work. That's one of the big reasons for the operational definition. So the easiest way to emphasize the operational definition is to contrast it with the conceptual definition. So the conceptual definition of a variable, very different from the operational definition. Your conceptual definition is what you get in your typical dictionary definition. So that's your typical dictionary definition. Your operational definition is not your dictionary definition. It is the set of procedures, the actual physical moves that you are going to do in order to measure that or manipulate that particular variable. So it's literally what are the operations that you do to measure this particular variable. So that's very important to know. You have to very well define the set of procedures that you're using. So, for example, depression. There's a conceptual definition of depression. There's an operational definition of depression. So the conceptual definition of depression is this is a condition of general emotional dejection and withdrawal. Sadness greater and more prolonged than that warranted by any objective reason. All right, so that's your conceptual definition. And if I told you that's what depression is, most of you it would make sense. You'd be like, oh yeah, that's what depression is. I get it. That's the syndrome of depression. And that's very useful. We need to have these conceptual definitions of what a variable is. But if I was researching depression, and you came into my lab and you said, oh, I want to participate in research. I want to be a research assistant. And I said, okay, great. I got a subject that's coming in, and I want you to measure their depression. And you say to me, all right, perfect. How do I do that? And I say, oh, okay, well, just measure their condition of general emotional dejection and withdrawal. Just measure if they have sadness greater and more prolonged than that warranted by objective reasoning. Go ahead, measure it. What do? You have no idea. You know what depression is, but you can't move on with the research because how do you get to this? How do you get to this internal number that a person has, this internal variable that a person has? Well, you get to it by the operational definition. So the operational definition for depression, one operational definition, is literally the score on the Beck's Depression Inventory. And if I told you when you walked in and wanted to be a research assistant, and I said, all right, great, I got a subject coming in today, I would like you to measure their depression, take this Beck's Depression Inventory, give it to them, ask them to read it, they get half an hour to finish it, and then we'll score it according to this answer key. In that case, you know exactly how to measure depression, you know exactly what to do. So on the one hand, this helps you understand what depression is, doesn't let you measure it whatsoever. On the other hand, this allows you to measure it, allows you to do the research, doesn't really tell you what it is. So if somebody who has never heard of depression asks you, oh, you're in psychology, what's depression? And you said, oh, well, it's the score you get when you fill out these papers, and I score it with this answer key. They'd be like, well, what is it? I don't even understand. Is it, is it my reaction time? Is it this? Is it this? This tells you very little about what it is, but it tells you how to measure it. So it's very, very important, because without this, you can't do the research. Without this, you're that research assistant stuck with this no operational definition that doesn't allow you to go forward. All right, so any questions on what an operational definition is? Perfect. All right, so we alluded to some benefits of operational definitions. This is the first one. It allows your variable to be studied. It literally allows you to do the research, and without it, you can't even start. So with that set of procedures, with this, there's literally nothing you can do. With that, you can measure depression. You can tell who's high on it, who's low on depression, who's in the middle. that will allow you to actually measure the variable, actually allow you to study and do the test. The other thing that an operational variable will do is it will force a scientist to discuss these abstract concepts in very concrete terms. It will force a scientist to get very precise about what they're talking about. It'll force a scientist to go away from the sort of hand-waving general definitions to something that is well-defined, precise, well thought out, makes sense. It's the only way to get to an operational definition. So if I was looking at depression, and I said it's a condition of general emotional dejection, if I want to translate this into an operational definition, I need to ask, what is emotional dejection? What does that look like? How can I measure it? What aspects are there to emotional dejection? What aspects are there to withdrawal? What aspects, how long is prolonged, right, than objective reason? How much is greater than objective reason? So those are the questions that were answered on the Beck's Depression Inventory, because they literally have questions where they're like, have you experienced sadness lasting longer than a day, lasting longer than a week, lasting longer than a month, right? They'll have those questions in there because somebody got very specific and precise on what is prolonged, how long is prolonged. So that's the other thing that it does. And I'll give you an outside of psychology, well, I guess it's still in psychology, example of this, but that comes from the Me Too movement. So the Me Too movement was a great example of the need of operational definitions in order to force people to discuss these abstract concepts in concrete terms. So if you remember, and this is actually from a while ago, and I can't believe the process for this is so slow. But anyways, I think Bill Cosby is the only one that's actually been sentenced from this movement. But when news about Harvey Weinstein broke, nobody was defending him. I shouldn't say nobody. Most people were not defending him. Most people looked at what he did and said, that is sexual assault. He sexually assaulted those women. When Kevin Spacey's incidences came out, most people, the vast majority, took a look at it and said, that is sexual assault. He sexually assaulted those men, right? So when these two came out, there was very little debate because they had operational definitions. They crossed the legal line that is very well established that this is what's legal on this side, and you've crossed over here. So it was very precisely defined. It was very well laid out. So when they mentioned, okay, these are his behaviors and these were Kevin Spacey's behaviors, everybody was like, oh yes, we've been very clear on that. That is sexual assault. That was the case with Weinstein and Spacey. That did not happen with Aziz Ansari. And the reason it didn't happen was because he didn't cross a well-specified boundary. He didn't do something that was illegal. So when people were saying, well, was it assault or was it just an awkward date? Was it his responsibility to make sure that she's okay, or was it her responsibility to say, I'm uncomfortable, I'm gonna leave? What was the situation? There was tons of debate on this, and I'm not gonna come out one side or the other, but I just wanna point out, if you went to any article and looked at the comments section, you would see about 50% of the people defending Aziz. You would see about 50% of the people condemning Aziz. If you went to articles about these two, you would see 98 of the people condemning their actions. And, the internet's the internet, so you know what the other 2% are doing. But importantly, their behavior was very well operationally defined as assault. Aziz's, not so well defined. So people had a hard time figuring out, is it not, because they were not clear about those abstract concepts. They were not clear about the abstract idea of this is assault, this is consent. They were not clear enough about that to say whether or not his behaviors fell into one camp or the other. All right, and the last thing about operational definitions that makes them very beneficial, very useful, is they help scientists communicate their ideas with others. Basically, it lets you tell a scientist exactly what you did and how you did it, and that lets you know if you're on the same page or if you're not on the same page. So I'll give you an example of this. Let's say that, again, we'll stick with depression. Let's say that you're looking in the effects of social media on depression. And there's a variety of different views on this. Some people are like, well, social media is causing depression. Other people are like, no, social media is actually a buffer against depression. So let's say that you are doing research and you're using the Beck's Depression Inventory, and your results indicate social media does not cause depression, right? That's what your results indicate. And then you get on the phone with another scientist who's doing similar research, and they say, oh, no, I've done what you've done. I've done the same experiment. Social media does cause depression. And you would say, no. Did you have a variety of subjects, males and females? And they're like, yes, we had a variety of subjects, males and females. And you're like, I don't know why I'm doing this. Did you have a variety of subjects, male and female? Yes, we did. Did you, do a pre-test and post-test? Yes, we did. Did you measure their hours on social media? Yes, that's exactly what we did. You did everything that we did. Yes, we did everything that you did. So why are we getting these two different results? Most of the time, it's because you're using different operational definitions. Most of the time, it's going to come out that you ran your study using the Beck's Depression Inventory. They ran their study using the Zung. This is another depression test questionnaire. I forget what the SDS stands for, but anyways, this is a different operational definition. This is a different way of measuring depression. So give them the Beck's Depression Inventory and score it. That's one operational definition. Give them the Zung depression test and score it. That's another operational definition. And once you figure out that those are your two different operational definitions, all of a sudden it makes sense why you might have gotten the result that social media does not cause depression. They might have gotten the result that social media does cause depression. And not only that, it tells you where to look. It also says whatever the Beck's Depression Inventory is measuring and whatever Zung's test is measuring, we can take a look at their tests and see what they're measuring differently, see what they might be emphasizing differently. It gives you a way in to, again, use those deduction skills and figure out it's got to be something with the difference between how those two are defining things. So it helps you communicate. Without the operational definition, those two scientists would have been going back and forth for years saying your study was not good, no, your study was not good, you didn't use a good measure, no, you didn't use it wouldn't progress the field. So these operational definitions help scientists communicate. All right, so any questions on operational definitions, their benefits, before we go on to relationships between variables? All right, so relationships between variables. This is one of the basic things that as psychologists we're trying to find, right? Basically, when I was giving this, the previous example, does social media cause depression? We want to know what's the relationship between those two variables. If you change social media, will that change a person's depression? That's what we're looking for. So that's what most research does. It's looking for the relationship between these two variables. And other ones is physical attractiveness related to perceptions of intelligence. There's a effect known as the halo effect, where it's been shown that people who are more attractive are perceived as being more intelligent. You'll see this in movies all the time, right? The intelligent heroes are usually the good-looking individuals. The not so smart, bumbling individuals typically not as good looking. They're taking advantage of this perception of physical attractiveness and intelligence. So when you ask a question like that, you're asking, do the levels of these two variables vary systematically together? So perceived attractiveness, where is it? Physical attractiveness is a variable, right? There's more or less in different individuals. Perceptions of intelligence is a variable. How intelligent you perceive somebody else to be changes depending upon how they look, what they're wearing, other factors. So they're variables, and we just want to know, do they vary systematically together? Another way to say this is, are physically attractive people perceived as more intelligent? Is the halo effect, actually at work here? Or maybe are physically attractive people perceived as less intelligent? So you always have those cliches. If you watch any sort of like high school romantic comedy, you know that the square-jawed captain of the football team, and you know that the blonde-haired leader of the cheerleaders, they're not that intelligent in this movie, right? So is that the relation? This is what psychology would try to figure out. So there's basic types of relationships. Typically, they'll fall in one of these four relations. The first one is no relation. This is one of the reasons why we need to use deductive reasoning. Most variables that human beings have, most individual characteristics that human beings have nothing to do with other individual characteristics that human beings have. So if you were just to randomly pick out variables about humans and say, are these two associated? The answer most of the time is going to be no, right? So is intelligence associated with eye color? No. Shoot. Is emotional stability associated with height? No. Shoot. That's why we need deductive reasoning to hone in on, let's look at these variables and let's look at these variables. So the first one is no relation. And what that looks like is if you got a graph that is showing perceived intelligence on the y-axis here, perceived attractiveness on the x-axis, that's what no relation looks like. It does not tell you anything. If you know that somebody is high in perceived attractiveness, they could be high in perceived intelligence, they could be low in perceived intelligence. If you know that they're low in perceived attractiveness, they could be low in perceived intelligence, they could be high. They're not related. And if we were to fit a straight line to this cloud of points, that's what the straight line would look like. It would be flat, indicating that there's no relationship whatsoever. So I kind of skipped this. Hopefully you knew this already, but each of these points is a measurement of the perceived attractiveness and perceived intelligence of an individual. So you would do something like show somebody 100 photographs, and you would say, on a scale of 1 to 10, how attractive are they? On a scale of 1 to 10, how intelligent do they look? And these are the scores that they would get. So each person has 2 scores, and that's where their dot ends up. So that's no relation. That's what most variables actually are. Most variables are not related to one another. All right, so the next relation, basic type, is positive linear. And positive linear means straight. Positive does not mean that this is a good relation to have. Positive does not mean that this is a beneficial relation to have. All that positive means is that if one variable increases, your other variable increases as well. So if perceived attractiveness and perceived intelligence were positively related, positive linear relation, that's what their cloud of points might look like. And if you fit a best line to that, you will see that as perceived attractiveness increases, so too in general does perceived intelligence. And if this was the case, this is your classic halo effect, where people that are more attractive are seen as more intelligent. So more attractiveness means more intelligence, less attractiveness means less intelligence. It's a positive linear relationship. Both variables go in the same direction. One increases, the other increases. If one decreases, the other one decreases. The opposite of the positive linear is the negative linear. The negative linear, again, linear for straight line. Negative does not mean it's a bad relation. It does not mean that it's harmful to a human being. All that it means is that as one variable gets bigger, the other variable gets smaller. So this would be the case if that cliche about the romantic comedies was correct. So if you have highly perceived attractiveness, this would indicate that people in general perceive you as lower in intelligence. And if you're unattractive, people in general perceive you as higher. So low attraction, high intelligence. High attraction, low intelligence. That's a negative relation. When one's going one way, the other variable goes the other way. All right, so those are the first three. We got one more to make you aware of, and that is the curvilinear relationship. And the curvilinear relationship is the not straight line relationship. So these ones here were all best described by a straight line. Curvilinear is something like this. So in a curvilinear relationship, low perceived attractiveness is actually associated with low perceived intelligence. High perceived attractiveness is also associated in this case with low perceived intelligence. There's that sweet spot right in the middle where people are perceived as having the highest intelligence. And this is curvilinear because a line that best fits this is not straight. It has to be curved. And if you fit a straight line to this, you'll actually find no relationship whatsoever, because that is the best straight line to try to fit all of these points. So I'll give you an example of a curvilinear relationship because they're always weird and interesting when you see them. The perception of music liking has been shown, and actually liking in most art has been shown to be on a curvilinear relationship. Let me see if I can get this video to go. And this has been, again, applied to popular music. So let's take a listen to just a kind of view of some of the kind of research that has been done on music perception and musical structures.
So, is there some sort of formula for a popular song? Well, a lot of research has gone into that. On his site, Music Machinery, software developer and orchestral trombonist Paul Lemire ran through a bunch of recent hits in his custom pattern.
All right, one sec. Let's see if I can get... There's never volume when you need it. Let's see. Let's see if this will work. No, that made it worse. Let's see if...
So those color patterns are beats, and those little connections inside the circle are sections of music that exactly line up. So you can see...
This is great, right? So I either get one or I get the other. Okay, so unfortunately, I'm going to provide the audio for this. Let me see if I can get this back. Okay, so what they've done in this particular research study that they're mentioning is they took a look at the beat patterns of different songs. They took a look at their structures. They took a look at the kind of repetitions and beat patterns of different popular songs. And what they noticed was that there's a certain structure to these songs. So this is a visual representation of those structures. So you have different parts of the songs. You got links between them. You got different, total beats, beats per minute. And that is, that was Rolling in the Deep before by Adele. Let me just do this a little back. So this is the structure for Rolling in the Deep by Adele. This is the structure, this next one. I'll pop it up. That's Paparazzi by Lady Gaga. That is TikTok by Kesha, Fearless, Taylor Swift. And you'll notice that they're basically the same structure. So when somebody, and then this is, just to kind of show you a different structure, this is not a pop song. This is, what do we got there? It's Led Zeppelin. It was Led Zeppelin. This thing's covering it up. So different songs have different structures. And what they found was that the current songs that are popular have a very specific structure. So when somebody who's highly critical of a genre says, well, all these songs sound the same, they're not that off, right? They all sound the same. There's a reason they all sound the same, and that's because of this, the effect, the curvilinear relationship between music enjoyment and music complexity. And this is something that you find in just about every art medium that there is. They've shown this curvilinear relationship. So music complexity, we saw there, is basically how complicated your music is. So some of those structures, like the Taylor Swift songs and the Adele songs, much simpler. Some of the other structures, a little bit more complex. And what you'll find is that for music that is very, very simple, either in how complex it actually is, or in how much you can process it, how well you can process it, that music to us is boring. So this song right here would be something like Row, Row, Row Your Boat. Row, row, row your boat. Very simplistic, very repetitive. You know, it's just like row, row, row your boat gently down the stream. I mean, it's very simplistic. I'm assuming nobody here has row, row, row your boat on their playlist, right? Nobody works out to, yeah, you do, you jam to row. So nobody here has row, row, row your boat on their playlist because it's too simple. It's not, it's just too, it doesn't lead to enjoyment. On the other hand, this is like the polytonal jazz experimental kind of music. The music where you put it on and you'll clear a room because it sounds like polytonal. You don't know that song? I figured if you have Row, Row, Row the Boat, you'll have that one too. It's massively complex. They don't use the typical structures. So it's massively complex. People hate it. People do not enjoy that music. What do they enjoy? They enjoy the stuff that's in the middle. So most pop songs, most songs that reach the top of the charts, they might be innovative. They might be, really new. They might have a different sound. They're right in the middle of complexity. They're not so simple that you're bored. They're not so complicated that you don't know what's going on. And that leads to the greatest enjoyment. And then this also explains what happens when you get into a genre. So there are people that will listen to those atonal composers. So people like Stephen Reich and the MIT engineers that used to do these computer-generated, types of music. Some people love it, right? Some people absolutely love that kind of music. And you've probably had the experience where a friend of yours has said, oh, you got to listen to this album is great. And you put it on and you're like, that's not that good, right? It's just not good. And then they're like, no, listen to it again. And you listen to it again and you're like, okay, I kind of get into it. And then after 4 or 5 listens, you're like, this is amazing. I don't understand how I didn't like it at the beginning. What's happening is on your first listen to these, you don't have the cognitive structures that are necessary to analyze this music. So it falls here. It's too complex. It's too much for you. But as you get practiced in that genre, the complexity goes down and the enjoyment goes up. So if you're listening to a new genre, a very complicated new piece of music, you'll probably end up here. But as you listen to it, as your mind is able to process it, that complexity goes down. And this curvilinear relationship says that as complexity goes down, enjoyment will go up. That's also why musicals tend to have simpler songs than you'll find in other genres, is because a musical, you need to enjoy it right away. You can't go to a musical and say, yeah, I'm going to shell out hundreds of dollars for this musical, and if I don't like it, I'll shell out another 100 and I'll go back again. And if I don't like it, I'll give it another chance. No, you got to go in and like it right away. That's why most successful musicals, right in that moment. Complex enough that you'll enjoy it, you'll find it interesting, but not enough where you need multiple listens in order to really get into it. All right, so we were going to talk about the relationship and reductionist of uncertainty, but this is not something we're going to be able to do in the 3 minutes that we got left. So yeah, we'll do this not next time because we're having a library visit, so a week from today. But before we wrap it up, any final questions on the relationship between variables, operational definitions, anything we covered today? All right, so that's it for today. So for next class, just I will make the announcement probably tomorrow. Check your announcements. I'll also put a sign outside the door here. We will not be meeting here. We'll be meeting in a room with computers, and I'll let you know exactly where that is. But other than that, we are done for